Okay, so we have a vector problem where we have an airplane and we know in which direction it's going, and we have some wind that's blowing in another direction, and we want to figure out what that wind is going to do to the airplane. So let's draw our stuff. The airplane is traveling at 45 degrees, and that means from due north. So here is your airplane's vector, 45 degrees, and that's 250 miles an hour. And there's a wind blowing from the north. From the north means it's blowing to the south at a wee 30 miles an hour. So there's a couple ways we can figure out where the resultant is going to be. One of them is by putting the wind at the end, and the resultant goes from the origin out to where those things meet. So it looks like the magnitude of the ground speed will be less than the actual, and it will be pushed a little bit further. So we're going to do this using the component method. So we're going to take the wind vector and write it as its x and y components. And we do that by multiplying the magnitude by the cosine of the angle. And we find the y value by taking the magnitude and multiplying it by the sine of the angle. And because sine and cosine are both 45, these should be both the same values. So they both have a vector x component of 176.78 and a y component of 176.78. Now the wind is going straight down, so the wind has a 0 x component to it and a negative 30 y component to it, because it's going straight down in the negative y direction and not left or right at all. So the resultant is going to be the sum of these two, which is 176.78 and negative 146.78. So that's the vector that represents the resultant of this wind slash airplane. So if we want to find the ground speed, that's really the magnitude of this resulting vector, which is 176.78 squared plus 146.78 squared. And yes, I know I am squaring this and it's a negative up there, but don't worry, when we square things, you always get positives. So your answer is going to come out the same as long as you parenthesize it in your calculator. So whenever I am squaring things in the calculator and it happens to be negative, I just leave off that negative, because the answer is the same either way. So the resulting ground speed is 229.77 miles per hour, and the angle is always found by taking the inverse tangent of the y value. Sorry, that's a positive anyway. I know you were wondering if that's a positive. The y value over the negative, the x value. And this will give us the angle formed with the x-axis. Okay, and I'll explain that in a second once I calculate it. That turns out to be 39.7 degrees. Okay, so 39.7 degrees is this, the angle formed with the x-axis, 39.7. So if we want the actual heading, we're going to have to come back here and figure out what is the heading from 0 degrees north. So if I subtract that from 180, that will give us our, subtract it from 90, not from 180, from 90. That will tell us what the angle from due north happens to be, and that is 50.3 degrees. So with an airspeed of 250 and a wind heading it at 30 miles an hour, it would actually be flying at 229 miles per hour at a heading of 50.3 degrees.